Well, I'll start with the knots in the wrong places. Yes.
Well, yeah, it gets started when they, if they scale a log in the water, they start looking at those types of defects.
Right.
I used to do that, and so they, the scalers would explain to me what shake rot was and what shake is and all of that. So I guess that's where that leads if you have those kind of defects.
Yeah, it does. And the ones to watch out for are the knots to watch out for are ones that are situated, that are really big and are situated right on the bottom of a beam. If they're on the top of the beam, they still have compression value. And that's one detail you've seen as the dovetail. With the timber framing, they actually take a dovetail out of the top of the beam, and that's cutting the beam. I mean, down 2.5 inches or whatever you're cutting. But their rationale was that they got a dovetail real tight.
Right.
So the compression value returned. And one thing that I've also done is to actually cut my dovetails with just a little bit loose in one spot, and then drive wedges. So you really tighten it up, and then if the wood shrinks, the wedge swells, and you kind of cover yourself for what might happen in the future. And the other kind of knots are on the side of the beam, what's called a spider knot. They're kind of like a horn, they look like, and they really detract from the strength also. But knots in the center and knots on the top edge are the center is the neutral axis, neither tension nor compression, so it doesn't matter there, and that's why you see the big holes for pipes and whatnot there. And then on the top, the compression values return. Pitch cracks and wind stress. The pitch cracks are more of a nuisance. If you had beams in your home, you would have maybe some pitch dripping from the ceiling and on your carpet if in green lumber. If it's kiln dried, the pitch sets and you're good to go that way. And spiral grain. This really isn't a structural problem as much as it is an aesthetic problem. What happens with spiral grain, anyone ever wondered why some posts and some beams corkscrew and others don't? Here's what after working with this and wondering and asking, here's the best answer that I have. We've got a timber with heart in it. So one of the things that a timber with heart in it will do is it will check, one face will check to the heart. The rest of the checks will be rather small, but one face will check to the heart and it'll open up big. And if there is sloped grain, so spiral grain to the beam, if you've got this face here, the grain slopes, and then this starts checking. This face decides to check. Every time it checks, it just kind of like a wrench or a ratchet, yeah. You just tweaks till it's done checking, and then you're done corkscrewing.
Unless it's hemlock, then it'll just keep right on going.
Yeah. Okay. So we covered the lateral bracing, tension loads, and then aero design eliminates OBS. And it was a while ago my guy had done this. It was something like overloaded beam syndrome or something. Because I mean, if I'm left to my own devices when the project's on the drawing board, it'll be big and it'll be heavy. And I can do delicate, intricate, embellished beams and perfectly proportioned timbers if that's what the client wants, but coming right out of the chute, left to my own devices, it'll be big, it'll be heavy, it'll be strong. And so that pretty much wraps up the presentation on critical factors. And I've got pictures and books here you can come up and take a look at, and we just kind of have informal questions. Yes?
We had issues on some of ours, and I usually don't get to do that many plans because I have to spend more time out in the field now. But we've had some where we had a lateral done by an engineer, and they do, and then they give us the engineered trusses, and the laterals is a framed brace system and stuff like that. And then we have some of this timber frame, but there's no engineering for it. Sometimes they'll say, well, it's decorative, but sometimes it's not quite decorative because it carries a little bit of the roof load, and then how it connects back to the structure. And I was just wondering how you present, or do you get involved in the presentation to the building department, and how does that usually work?
A lot of times I will, and what I do is I just draw up connection details. It's pretty basic. I mean, you guys got to get a good connection and understand what you're trying to do as far as...
It's like, too, where you have that big overhang like that. I suppose that needs to be engineered, right? So, I mean, when you have a big canopy entrance. But then how it ties back into the structure and how it
definitely. Yeah, structure. you gotta address the connections.
Most of the time, my experience with this stuff, I'll share, is when you're doing a separate structure, it's like an entry or a porch or a back deal like that, I've generally had design criteria for that. I've done some of the timber frame houses where they have the timber frame and then like the foam panels that secure to it, and they're two separate structures. And what I found that's missing is the connection from one structure to the other.
Right.
I'll have a lot of really good design stuff for the timber frame portion of it, and I have a lot of good design stuff for all the strands and all the panels and everything else, but how they connect and the schedule for which they connect is generally missing.
Yeah, and I think what happens is, okay, you design the bracing or what have you for the front end of it, and the back end of it, the lateral loads go into the main structure, and how they, or you might even have some overturning, and you might have some rotation, and so forth. And sometimes that's not always detailed how it goes into the main structure and gets distributed that way.
Especially if like Jim had said, where there's a SIPS manufacturer and a timber frame, there are two different providers.
Right.
There's one like this. By others.
Right. Exactly. No, it's engineering here, engineering there.
Right. By others.
Yeah.
Okay, so before we get going on the books, I don't know how we should handle this the best, but I should somehow have some way of forwarding a link to all you guys, so you'll be able to solicit, improvements, comments. I'll get this up on a web page, and
so I can send it out to our general membership list.
Anyone who you think would have any interest and be able to leave some valuable comments, hey, what kind of questions like you guys were asking? That's the questions are really what bring a lot of the gems to the surface.
Good.
Okay.
Great.
I know I had,
Yeah.
he did some stuff on the house out here for New Tradition. They put some stuff all the way around it, some gingerbread on it. And part of it actually was supporting a roof, And I had never really been around it a lot, the gingerbread part. I didn't know who was doing it or anything, and so I called a meeting for it, and then remember we met out there.
Where's my cows? Well, and I'm like, hey, we're holding up a roof. I got to know what's going on here. What are we screwing on with? Because it was done. And so he come out and he showed me kind of a drawing of how it all worked, and it showed me how it was clevised and stuff, and I just went, yeah, it looks good. It was overbuilt max, you could tell. So. But at first I was a little skeptical too. I thought,
well,
you just got a little wood screw behind here. What's going on?
Right. He couldn't see that the bottom was
Clevis
in.
Yeah.
So you don't have a problem.
It was such a tight fit,
Yeah.
I went to
that was it. It was such a tight fit.
So you don't have problems with those when you go in that tungsten roofing. You don't have an issue with that or that mortise in there. You don't have problems with those shearing off.
With enough force, anything will shear. And that's where you have to calculate how much meat you leave on the tenon. You're looking at, you've got your perpendicular to grain where the mortise is, your parallel to grain where the tenon is, and so you're going to maximize that. You don't want to make your tenon 2 times stronger than your mortise.
Doesn't do any good.
Right.
Yeah.
I went out on the field on one a week ago or whatever, and this is kind of typical. I've seen the other ones too. This one was in Washougal. It's like about 10 acres. You got to drive, I don't know, quarter mile or a half a mile to get just to the site, and it's right on a hill, and it's got 180-degree view of the river. But the house is pretty good size. But the most impressive part of it is, they got this entryway living room area, this big, high-pitched roof that's all done in this timber frame. But you got these timbers that some of them are like 15 by 15 solid timbers. I mean, my God. And I says, well, this looks a little spendy. He goes, yeah, especially since just for the package was $165,000.
For the wood, for the
For
timbers.
the wood, for the timber frame. So, I mean, I imagine this gets a little spendy, and then you throw on top the labor for all the connections and everything. I mean, this is not exactly your poor man's housing
No.
solution.
No.
No.
No, there is, in fact, I just got a publication from Timber Framers Guild. I'm a member of the Timber Framers Guild. And, just like I referred to the guys who will actually go out and cut their own trees down and square them up all by hand and this kind of a mindset. Now, if they enjoy it, great. If that's their pastime, fine. What I also see in the timber frame industry is the same mentality applied to the realistic basics of making a living. Try to say that you can timber frame a house for less than conventionally framed, and it's an uphill argument.
Yeah, I would say that'd be a hard
I
sell.
think your
right there.
members would have to get a little bit downsized and make the components work
Well,
or something. Because
the
I
twist
can't
on-
imagine that lumber that big.
Well, the twist on
30-foot
it is
long
that
is
you're
cheap.
cutting, that you're maximizing your wood use because you're using bigger pieces further
Oh, I
apart.
see. But hell, you'd have to use an old growth tree to get some of those pieces out of there.
Yeah, there's it's
Well, it's not gonna be your standard dingbat frame that way,
No.
Lou.
no, and there is cost-effective ways to do it,
Yeah.
and it doesn't all have to be like the ultra affluent package.
Have you done any barns, old-fashioned barns for anybody?
Yeah, I did. One in it was post and beam, so it had metal brackets and it was had the plates on it and whatnot. But it's this typical barn, with the higher part with the loft and the
Yeah.
shed roof
Oh,
side.
yeah, right,
Yeah.
Nice.
Okay. Well, I'm wrapped up. If there's any more questions, or are you guys interested in the books? Or are you guys going to pretty much wrap it up and go?
Yeah, pretty much. I
Okay.
mean,
Yeah, I didn't know how much time we
people
have
may
left
stay here
over.
for a few more minutes. Yeah.
Luke,
Oh, yeah. Go ahead, Ken. Anyway, I'd like to thank
Yeah,
you for
you bet.
giving us this presentation.